Portion of the curve f of x equals square root of 9 minus 2x from x equals 0 to 4 is shown below. This curve is rotated around the x-axis. It's an important word there. Rotated around the x-axis. So they're going to take this little curve right here, and then here's the x-axis. They're going to rotate it around the x-axis. So it's going to come down here and make some kind of bowl thing. In fact, I graphed it here on the Calcplot 3D so you could see it. So here's our shape. It's been rotated. Here it is flat. I put in the function there, and here it is rotated as a three-dimensional shape. So we want to know what's that surface area, that cup, that coffee cup kind of shape. What's the surface area? So it says here, set up an integral with respect to x that gives the area of the surface area. Okay, so there's the answer. How'd they come up with that? Well, if we go to the surface area formula, arc length and surface area on the note, surface area. We're down here, so we're not doing arc length, we're doing surface area. About the x-axis or y, remember it was about the x-axis. So we're looking at these two, well, yeah, it's really two formulas in one right here about the x-axis. So there it is. Let's do the first one. So it's this, but the ds is either this if you want to do dx, or it's this if you want to do dy. They have us do both. Right, this will be the dx, this will be the dy. All right, so let's do the first one. So I'll just do this one right up here. So it's going to equal the integral from a to b of 2 pi y square root of 1 plus f prime of x squared dx. Make sure I get that right. Right, so it's very similar to the arc length formula. So 2 pi y and then ds, and ds is square root of 1 plus f prime of x squared dx. And then we'll do the y one in a minute. All right, so let's do it. So the a to b, this is a and this is b because we're going along the x-axis. So that will be from 0 to 4, 2 pi. Now what's y? Well, remember, y is the same as f. Function values are y values. G of x, h of x, f of x, they're all y values. So 2 pi square root of 9 minus 2x times the square root, do that so well, square root of 1 plus, no, we need f prime. So let's get that. So if f of x again is 9 minus 2x to the half power, right? Just grabbing it right there. Then f prime of x is bring down the half, 9 minus 2x to the minus a half, times root of the inside, which would be negative 2, right? Remember the chain rule. You do the outside, subtract, right? I subtracted I brought this down, subtract 1 from the power, but then chain rule says multiply by the derivative of the inside. Okay, then these guys multiply negative 2 times a half, so f prime will be negative 1, 9 minus 2x to the minus half, right? Negative 2 times a half is negative 1. Okay, so bring that up and put it right in here. So I'm going to go negative 1. Well, here, let me use a bracket for clarity. Negative 1 times 9 minus 2x to the minus a half squared dx, right? So I just popped that in right there, f prime of x. Okay, so now we've got to do some simplification there. So, yeah. So it's going to become the integral. In fact, I should probably just give it more space here. The integral 0 to 4 of 2 pi square root 9 minus 2x. Just bringing these parts down. Okay, and now this part I'm going to clean up a little bit. Square root of 1 plus. Now when you square this, right, it's all squared, square the negative, it's going to become positive. And what's going to happen? This power is going to multiply that power. Remember, powers outside parentheses multiply powers inside parentheses. Remember those rules? If you have x squared to the third, that's x to the sixth. That 3 multiplies 2. So powers outside parentheses multiply powers inside parentheses. So that's going to be 9 minus 2x to the negative 1, right? Because 2, half of 2 is 1, and negative times positive is negative. Like that. All right. Dx. Now what's going to happen from here? Well, now we're going to do a little bit of a tricky step. Let me show you. So again, the 2 pi is just sitting here. So now these are both square roots. So they can multiply and become one big square root. They're both under square roots together. So then I can just say, oh, okay. So it's just 9 minus 2x and 1 plus 9 minus 2x to the minus 1 dx. Right? So I just multiplied this and this together under one big square root since they both were under square roots. Okay, so now let's keep going. So integral 0 to 4, 2 pi. Now let's simplify that big square root. So I'm going to treat the whole, I know you might think about this like, um, foil, but here's a better way. I'm going to take this whole thing and I'm going to go boom and boom. Is that making sense? So rather than you might think, well, Mr. Should we take the 9 separately? And yeah, we could do that. But I'm seeing that this and this are going to cancel to be 1. Do you see that? So I want to keep this intact. So both things are true, right? You can take the whole chunk and say this whole big chunk goes boom and boom. That's true. Or you could go separately these two. And both are true. Just whichever way you want to multiply it out. And I'm saying this big old chunk is going to hit this, and the positive 1 and the minus 1 are going to add to be 0. It's going to be a big 1. So I'm going to go, okay. So this is going to be 9 minus 2x times 1 plus 9 minus 2x times 9 minus 2x to the minus 1. Do you see that? I just distributed the 9 minus 2x to each one separately. And so, almost got this first part. Second part will be a lot easier. Um, And then we've got, okay, 9 minus 2x times 1. That's easy. This is 9 minus 2x plus. Now, what happens here? 9 minus 2x times 9 minus 2x to the minus 1. Remember, this is an invisible positive 1 power, right? No powers on it, so it means positive 1. Powers add, going to be 0. Going to be 9 minus 2x to the 0. That whole thing's 1. Now, did I just lose you there? Let me remind you. If you have x to the minus 1 times x, well, here, let's just do plain numbers. If you have x squared times x cubed, right? You know the powers add to be x to the fifth. Well, same thing is true if you have x to the minus 1 times x to the positive 1. Powers add to be x to the 0. Anything 0 power, the whole thing's 1. That's what we're having here. We have a big old thing without a power, which means an invisible understood plus 1 power. And this to the minus 1, and these two powers add to be 0 power. And so that is super convenient, isn't it? It's going to be the square, got to do my root a little bit better there. Square root of 9 minus 2x plus 1. That, and then a dx, of course. So that thing right here just became 1. Anything to 0 power is 1. So there we go. There's our first answer. 9 minus 2x plus 1. And you can make that 9 and 1 10. I'm just done playing with it, honestly. And you could have stopped earlier, probably. But there we go. That's how they got what they got. All right. Now the second part. Let's do the second part. Now they want us to do it. So we're not going to actually compute that integral. You could type it into Google. I'm sorry, into Desmos graphing, and you get an answer. We could even do it by hand. Yeah, we could do this integral by hand. Just let you make this 10 minus 2x and do a u sub, and we could do it by hand. We're just not doing that. We're just setting up. And you can find all that surface area right there. Surface area, the outside of that coffee cup shape. Now, and we're going to do it the other way now. You can also, we did a dx. Watch how much easier the dy will be. It's going to come out with a really nice, easy formula. So now we're doing the dy. So coming down here, so again, you can do the dx or the dy. We're doing the dy now. There's the formula, 2 pi y ds, and then there's the ds. Okay. So It's going to be the integral from a to b, 2 pi y, and then this is the other one. It's going to be 1 plus g prime of y squared dy. So I just grabbed this formula right here and I put the whole ds right there. Okay. So now, so this is the dictator, dy, right? The last one was dx, everything had to be in terms of x. This is dy, everything's got to be in terms of y. So that y we're just going to leave as y. No big deal. Whereas the last time we had, the last one we had the 2 pi y, we had to plug in what y equaled, right? Because we wanted to get in terms of x, that was dx. Okay, but now we're doing dy. So just leave that y. That's already a nicer step right there. Now, what's this g prime of y stuff? Well, that's all about our function. So we got to go back to our original function right here. F of x or y is the square root of 9 minus 2x. Let me do that over here on the side. So we've got y is the square root of 9 minus 2x. This means we need a function of y, which means we need x. We got to solve this equation for x. That's what it means when they say g prime of y. They want g as a function of y. I mean, they want something in terms of y, which means get x alone, you'll have it in terms of y. So that's what we're going to do. I'm going to square that side, square that side. Squaring cancels rooting. So then we get y squared is 9 minus 2x. Um, I just I just like to jump things around. I'm going to take that minus 2x and jump it over here and that y squared and jump it over there. Whenever things jump to the other side, they switch signs, right? I'm just adding, subtracting to both sides. So positive 2x is 9 minus y squared because that positive y squared jumped to the side became negative. And then divide by 2, divide by 2, divide by 2. Boom. So x equals I'll just say 4.5, so go with the decimal minus a half y squared. Okay, so that is my function of y. They're calling it g of y. You call it George, whatever you want to call it. It's a function of y, right? It's a function that has y in it. That's what they mean when they say g prime of y. They mean take the relationship on the curve, this curve that we're rotating, this little curve, right? Here's the equation. That's a relationship between x and y, right? The points along that little curve, the x and y values of every point on that curve relate to each other according to that equation. That's what an equation is, a relationship, like a friendship between x and y. You can get x alone or you can get y alone. You can express it as a function of x or as a function of y. So with the other formula, they want us to express it as a function of y. So I took the little equation, solved for x, and that we're calling it g of y. You could call it anything of y, Joe of y, George of y if you want. There it is, a function of y. So now we got to go beyond that though. We need g prime of y, right? G prime of y. Take the derivative, that just goes to 0. Bring that down, so it'll be minus 1 y, subtract 1 from it to the 1, meaning it's just minus y. Isn't that beautiful? See how much easier this is going to be? So let's bring it back. We're almost there. Oh, what's a to b, by the way? Or do they call it a to b or do they call it c to d? I'm going up and down. Sorry if I'm making you dizzy. Yeah, A to B, whatever you want to call it, A to B. But remember, it's on the y-axis now. It's going to go from 1 to 3 because we're doing dy. We're on the y-axis. So the bottom to the top of that little curve on the y-axis is 1 to 3. So we're going 1 to 3 now because this is a dy. So 2 pi y square root of 1 plus, and what's g prime of y? It's g prime of y is just negative y. It's beautiful. Negative y squared. Isn't that nice? dy, and so basically we're there. 1 to 3, 2 pi y, square root of 1 plus y. The negative, just gets canceled out by the squaring. And there it is. 2 pi y squared to 1 plus y squared. 2 pi y squared to 1 plus y squared. So that's why we have two formulas, and it goes 1 to 3. Because sometimes one's easier than the other, and we can see this one came out a lot nicer. It didn't have to mess with all them fancy square roots and power stuff. Just came out really nice. The derivative just came out to be negative y, and plug it in, and this just stayed y. So there we go. Those formulas will give you the surface area of that coffee cup shape.